Now let's talk about volume. If you could build this at your table, I would ask you to build a rectangle with a length of 5 cubes and a width of 3 cubes. And I better put my camera up there so I can see what you're seeing. If you could build a 5 by 3 rectangle out of cubes, this is what it would look like. But then the next question I would ask was, if this were truly a rectangle, what would you see when you look at it this way? So you see this 5 by 3 rectangle, but when you look at it this way, you wouldn't see anything, because a rectangle is two-dimensional. So it has no dimension, no thickness. It just has length and width, or base and height. So when you turn it this way, it would disappear. But the reason you can see this one is because it's not a rectangle, it's a rectangular prism. It's three-dimensional. It's not made up of squares, it's made up of cubes. So three-dimensional space is cubic units, two-dimensional space is square units. You're very familiar with square units, we did a whole unit on that. So this, if this really were a rectangle, a 5 by 3 rectangle, it would be 15 inches squared or centimeters squared. But when you start to realize, oh no, it's made up of cubes, it's 15 cubes of three-dimensional space, that's 15 inches cubed or 15 centimeters cubed. It's 15, literally 15 of these cubes to make it. It's a rectangular prism. It's a rectangular prism. I shouldn't rush. Rectangular prism. The area of the rectangle would be 15 centimeters squared, because if we're talking about a rectangle, we're talking about a two-dimensional shape. But as we said, we're counting cubes, so it took 15 cubes to make the rectangular prism. So the volume is 15, not centimeters squared, but centimeters cubed. And this is why we say, when we say to the third power, this is why it's called a cubed, because it's literally made up of cubes. How many cubes of three-dimensional space? Of three-dimensional space. That's also why it's a 3D. So the next question is, could we have a prism with the same base, same 5 by 3 base, but a different volume than 15? And the answer is yes. If you have another one and you stick them, if you stick this one on top of this one, you still have 5 by 3 as your base, but now you've got 2 layers of 15 cubes. 2 layers of 15 cubes. So 15 times 2 for a total of 30 cubes. If I had another one, stick it on that, now I've got 45 cubes. 15, 15, 15. 15, the area of the base, times 3 layers, 45 cubes. Fifteen times 4, 60 cubes. So it's still the same area, but just how many layers of that area. This is the property of a prism. If you cut it parallel to the base, you keep getting that same 5 by 3 rectangle. And so there's a very nice formula for area of a prism that we're gonna learn here in a minute. If you've done length times width times height for rectangular prisms, this is why it works. Length times width will give you the area of the base times height. How many of those 15s do you have? I have 4 layers of 15. The formula we're going to use is not length times width times height, although you're welcome to use it, but it'll be very specifically for rectangular prisms only. The better formula to learn is volume equals big B times H. Big B, don't use little b. Little b means, little b is one-dimensional, like a distance. Big B is an area. Big B is the area of the base of the prism. the area of the base of this prism is 15. So if you take that area of the prism and multiply it by the height of the prism, then you've got your volume. And our rectangle, big B, since it was a rectangle, we use base times height. So 5 times 3 is 15. And the height is 4 because we had 4 layers. And so the volume would be 15 times 4, or 60 cubes, or 60 centimeters cubed if each side of those cubes was 1 centimeter. Now, I've been eating a lot of this stuff lately. Maybe you have too. Delicious canned fish. Comes in cylindrical packages. We've got the easy open one. All right, so this is definitely not a prism because it's not a polyhedron. They do like a spokesmodel. Delicious canned fish. It's not a prism because that's not a polygon, but it's prism-like because it has 2 parallel and congruent bases. They just happen to be circles. If the area of that circle was 8 square inches and this was 1 inch tall, this can, I would have 8 cubic inches of delicious tuna. But if I have 4 cans of delicious tuna, then I would have 8 square inches times 4 inches tall, or 32 cubic inches of delicious tuna. So in the same way that this is 15 times 4, this would be 8 times 4, or 32. 60 cubic centimeters, 32 cubic inches. I'm making up the numbers, but you get the idea. It's just big B, area of the base, multiplied by the height. How far apart are those circles? How far apart are these rectangles? They're 4 inches apart, or 4 centimeters apart, so 15 times 4. 4 layers of 15. 4 layers of 8. So the answer to this one would be 8 inches cubed for 1 can. If I stack 4 cans, oops, got ahead of myself. If I stack 4 cans, it would just be area of the base multiplied by the height. Well, this is the area, almost messed up. The area of the circular base we said was 8 inches squared. So B equals 8 inches squared. So the volume would be 8 multiplied by the height. 4 cans, each can's an inch, so times 4. So 32 inches cubed of a delicious canned tuna. Here's the nice thing. For all prisms and cylinders, because cylinder is like a circular prism, acts just like a prism, all you have to do to find volume is find area of the base and multiply it by the height. The height is the distance between the bases. Now these have all been drawn nicely where the bases are the top and the bottom, but you know that that won't always be the case. But for example, this triangular prism, you find the area of this triangle and find how far apart these triangular bases are, the height, how far apart are they, and there's your volume. So we'll practice with this. I've given you a reference. All of these will look familiar because we did a long unit on this. If your base was a triangle, you would find the area of the base using this formula. If your base was a trapezoid, you would use this formula. If your base was a parallelogram, like a cube or a rectangular prism, you would use base times height, like this example I was showing you.